China's asteroid sample return mission launches. Searching for a companion star for Betelgeuse. Starship and Superheavy wrap up their 9th test flight. Webb takes its longest exposure ever. And in SpaceBites Plus, is Venus hiding deadly asteroids? All this and more in this week's SpaceBites. And in SpaceBites Plus, SpaceButts? Yes, that's our OnlyFans version of SpaceButts. Yeah. All right, let's start this week's episode with a mystery. And this is a peculiar object, and I'll let you know right now, we have no idea what it is. But here's what it does. Astronomers detected an object that was making a regular radio pulse every 44 minutes. And this isn't unusual, right? There's objects called pulsars. Every 44 minutes is a bit long. Pulsars can release dozens, if not hundreds of pulses in a minute. And yet there are some long period pulsars that can go several minutes per pulse. But what makes it really strange is that astronomers also detected a 44-minute X-ray pulse coming from this object. And that's weird. That's never been seen before. And now astronomers don't know what it is. For the radio observations, the astronomers use the Square Kilometre Array Pathfinder in Australia. And then for the X-ray observations, they use the Chandra X-ray Observatory. So what is this thing? Well, the astronomers have no idea. And this is a class of object that has never been seen before. Now, you've got your standard laundry list of possibilities that there's two objects, maybe a white dwarf and a neutron star, or a white dwarf and a black hole, or two stars, and that they're interacting in some way where one object is pulling material off from the other. But the challenge is that you're getting both these radio emissions, but then also the X-ray emissions at the same time, which are the opposite ends of the electromagnetic spectrum, but not in between. One idea is that it's a magnetar, and you can get releases of both radio waves and X-rays from these objects because they have these magnetic reconnections, but they don't happen on a regular basis. And so the best idea that the astronomers have right now is that there's some kind of interaction between a white dwarf star, which is a dead star like our own sun, and some kind of companion star. But the only way that's possible is if the white dwarf has the most powerful magnetic field that's ever been seen on a white dwarf star. So it's an unfolding mystery. It could lead to an entirely new class of objects, and we're gonna have to wait to find out exactly what this thing is. Speaking of possible binary stars, I just spoiled the story. Okay, Betelgeuse is a variable star. It is a red supergiant that is nearing the very end of its life. It's only about 10 million years old, and yet it has burned through its fuel. It's about to detonate as a supernova. When it's going to happen, we don't know. Sometime in the next, million years or so. It goes through a regular period of variability. It gets brighter and dimmer. And part of this is well understood, that Betelgeuse is this red supergiant star. It goes through this period of variation as it's going through its death throes. But it has another periodic brightness that has been a lot harder to explain. It lasts every 2,100 days. And astronomers have proposed various ideas that there's some other kind of oscillation that's part of its pulsation. But a really interesting idea is that there is a companion star in orbit around Betelgeuse that takes 2,100 days to complete an orbit. But because it is so close to the star, there's no way for us to be able to observe it directly, only to measure the changes in brightness at Betelgeuse as this star is going around. So sometimes it's behind it, and so the star looks dimmer. Sometimes it's off to the side, and so that makes Betelgeuse look brighter. Sometimes it's lost in front, and so it's lost in the glare. So astronomers use the Hubble Space Telescope, and they timed their observations to exactly the point where if there is a companion star, it would be at its greatest distance away, sort of watching when it is on one side of Betelgeuse. They made their observations, and they were unable to distinguish a separate star from Betelgeuse. And in theory, so this star is going to be orbiting Betelgeuse every 6 years at a distance of 9 astronomical units, which is like just a little outside the star itself. They didn't detect the star, but that allows them to constrain the size of the companion. It means that it can't be brighter, bigger than about 1.5 solar masses, but it can be less. And so there still could be a star in orbit around Betelgeuse. We're just going to need better instruments, better resolution to be able to separate Betelgeuse and a companion star. We've got a story about this on Universe Today from Mark Thompson. Now we're going to have a bunch of rocket launch news. First up, the Chinese space agency's Tianwen-2 mission just blasted off earlier this week. Now, Tianwen-1, that was the Mars rover and had an orbiter rover. The rover has since died, but they got a lot of interesting science. Tianwen-2, this is their asteroid sample return mission. The asteroid is called 469219 Kamoalewa, which is thought to be a fragment of the moon. It's only 40 to 100 meters across, which will make it the smallest asteroid ever visited by a space mission. It's going to stay in orbit around this asteroid for about a year, and it's going to descend down to the surface and deploy a lander and attempt to collect a sample, the sort of similar bounce off the surface and collect a couple of 100 grams of material. It'll then return that material to Earth, and then it will continue on to go to its second target, which is Comet 311P Pan-STARRS, and will arrive there in 2035 and then go into orbit and learn as much as it can about this object. And so you're going to get this combination of an asteroid visit, an asteroid sample return, and then a visit to a comet, which is a pretty cool stack. China is planning out future Tianwen missions. So Tianwen-3, that's going to be their Mars sample return mission. And then Tianwen-4 is going to be a mission to Jupiter. So a lot of interesting missions coming out of China. We've got a story about this on Universe Today from Mark Thompson. And then we got a test of a Chinese reusable rocket. This is from a company called SpaceBites, and they did a test of their Yanqingzhe-1 rocket. And they launched it on Thursday this week. So the rocket took off. It's a methane liquid oxygen rocket. It took off, flew to an altitude of 2.5 kilometers, and then descended back down, reignited the engines, and then hovered just above the ocean off the coast, and then did a soft landing in the water. Now, this rocket looks very familiar, obviously, very similar to a Falcon 9 booster. It's a little bit shorter, only 26.8 meters tall, but it's a little bit wider than a Falcon 9. It's 4.2 meters in diameter. With this test flight complete, they're moving towards doing a full orbital flight, probably later on this year. And that rocket is going to be called Hiker 1. And in fact, there's about 5 different Chinese companies that are working on various reusable rockets. So I think we're going to see a flurry of these kinds of tests over the next couple of years, and we should see more companies starting to be able to do reusable flights coming out of China. And speaking of reusable rockets, this week we saw the 9th test of the Starship and Superheavy booster from SpaceX. Now, the goal this time around was to use an already been flown booster. They also wanted to test out the PEZ dispenser. This is the Starlink deployment door on Starship. And then, of course, they wanted to find out if they could perform some orbital maneuvers and to be able to land softly in the ocean. But also they wanted to avoid the propellant leaks and destruction that they saw in the last 2 launches. So the launch started out perfectly. You got this incredible launch from this reused Super Heavy booster, and then you got to the point where the Starship detached from Super Heavy. Super Heavy made some very aggressive return maneuvers. They wanted to push this booster to its absolute limits, and they were able to complete that, and then it broke up on its way to a landing in the ocean. They weren't even planning to recover the booster. So that all went according to plan. And that was sort of the last big success of the mission, was that they flew a reused booster rocket, which is pretty cool. Then Starship headed off into an orbital trajectory. They tried to test out the PEZ dispenser, the door that allows it to deploy Starlinks, and that didn't open up. Then you could see that there was a roll on the spacecraft. It was starting to tumble out of control. And it became very clear that it was having a propellant leak. We learned later on that that's what it was. and it tumbled and broke up as it was re-entering the atmosphere. So that's another loss of Starship. That's 3 in a row. Whatever they're doing, they haven't been able to crack these problems with Starship. So that's it for the next test of Starship. And now we're going to wait, I guess, for the 10th test of Starship. But obviously, time is running out. This needs to be used for the Artemis 3 missions, which should be launching in 2026. But come on, it's going to be later. And we've got great coverage of this from Alan Boyle on Universe Today. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner from last week was that Jupiter was once twice as big in the past. So thank you everybody who voted. Now, when you're watching this video, we will put the vote onto the post tab on our YouTube channel. And so if you're scrolling through YouTube and you see the vote come up, just take a second and let us know what you thought was the best story. Now, of course, if you want the best chance to see it, subscribe to the channel, click on the notifications bell, and then just interact to let the algorithm know that you want to see more of this. Now we've got some cool supermassive black hole news. First up, a proposal to do a color image using the Event Horizon Telescope. Now, we've seen images of the shadows of the event horizon for the supermassive black hole M87, as well as the one at the heart of the Milky Way. And these are done in radio waves. So you've got this worldwide network of radio telescopes that all are looking at the same object at the same time. They make a virtual telescope the size of planet Earth. And now astronomers think that they can do something even better, which is to take a multicolor image of the black hole. Now, obviously, multicolor images, that's not very complicated. We do this all the time in other wavelengths. Most of the telescope images that you see were done in multiple wavelengths. And sort of this becomes really tricky when the target that you're trying to observe is very small or it's moving very quickly. And black holes, even though they're very big, are very small in the sky and they can be very active. Imagine you're taking an image of something that's happening very quickly and you're taking a second in between exposing the image in each of the colors. They're not going to line up. And so you're going to get something very weird. And so an image of a supermassive black hole, they're actually some of the smallest objects that we have ever observed with our telescopes. You need a telescope the size of planet Earth. Astronomers have figured out a way to be able to observe with 2 wavelengths of radio waves at the same time. In fact, they're able to use a 1 millimeter wavelength image to enhance the 3 millimeter image wavelength that they're doing at the same time. And so it's kind of similar to how astronomers use adaptive optics, where they fire a laser into the space, then they use that artificial star as a way to remove the atmospheric distortions. And so the astronomers have proposed that they can observe a supermassive black hole with the Event Horizon Telescope or with one of the follow-on giant telescopes in multiple wavelengths. That will allow you to reveal different aspects of the event horizon at the same time. We've got a really interesting story about this from Brian Coberline. Here's the second Event Horizon Telescope story, and it's all about how astronomers are continuing to study the supermassive black hole at the heart of M87. This was the first black hole event horizon that we ever saw. And then astronomers did follow-on observations where they were able to measure the polarization, essentially the magnetic fields around these supermassive black holes. Now, astronomers have made 2 more really important observations about this black hole. First, we know how fast it's spinning. And measuring the spin of a black hole is complicated because you can't actually see the black hole. How do you know how fast it's spinning? Well, when a black hole spins, it tangles up space-time around it. This process called frame dragging. And you can measure the movement of the material that is orbiting around the black hole as it's getting caught up in this frame dragging. And the faster the black hole is spinning, the closer the accretion disk can get to the event horizon of the black hole. So astronomers made these measurements from the Event Horizon Telescope image, and they were able to calculate that the black hole is spinning at 80% the speed of light. In other words, if the event horizon had a surface, which it doesn't, then that surface would be going at 80% the speed of light. And the maximum speed is 99.8% the speed of light. So it's turning pretty quickly. And it's thought that you can only get a really rapid rotation like this after a fairly catastrophic merger between black holes, or a black hole that fed very aggressively. Very slow feeding black holes don't spin up this quickly. The second piece of information that astronomers got is the speed that it's accreting material. How much new mass is M87 adding every year? And this is a very wide range. So they don't have an exact number yet, but it's somewhere between 13 times the mass of the Earth and about 40% the mass of the sun, which is like 365,000 Earths. Anyway, it's somewhere in between there is the amount of material that it's adding, but it's not like less than the moon or thousands of suns. It's adding roughly that amount of material to itself every year. And finally, I'd like to show you a really nice image. This is probably the longest exposure image that has ever been taken by the James Webb Space Telescope. This is the galaxy cluster Abell S 1063. And this is a huge cluster of galaxies that's about 4.5 billion light years away. And I'm sure you can see all of the streaks and stripes that are in this image. And those are galaxies that are being lensed by the gravity of the foreground galaxy cluster. Webb spent 120 hours making this image, and it is just ludicrous, especially if you go and download the full resolution version and look around. You could see all of the little galaxies at the very limits of what Webb can see. What's really cool is we can get a comparison of this image versus what was taken with the Hubble Space Telescope. Hubble imaged this object for 140 orbits, so that's going to be longer than the amount of time that Webb took to be able to image this same object. And yet the Webb version is so much more detailed, so many more galaxies inside this image. It's really incredible. And so this is just great. Like one of the longest images taken by Hubble versus one of the longest images taken by Webb. We've got a great story by Evan Goff on Universe Today. Do you want even more space news? Well, I'm writing my weekly email newsletter, which covers 30 to 40 space news stories that we're reporting over on Universe Today. For example, Perseverance was photobombed by a dust devil passing through its background. We've got a story about that from Mark Thompson. This is a cool story about how if we develop artificial intelligence to be part of an interstellar mission, will the AI remain coherent over a long period of time? And will it be able to adapt when it finally arrives at its destination? And we've got a story about whether an AI can stay sane for an interstellar mission by Evan Goff. And here's a story about how space power satellites could be used to keep a base on the moon warm through the lunar night, which, we've talked about this being a big problem all the time. We've got a story about that from Mark Thompson on Universe Today. Now, my weekly newsletter goes out every Friday to 72,000 of my closest friends. I write every single word in it. There's no ads in it, and you can sign up completely for free. Just go to universetoday.com/newsletter to sign up. We've got another version of this episode with no ads and one additional story, and we call that SpaceBites Plus. You can check it out on patreon.com. This week's bonus story is Venus hiding dangerous asteroids, and I'll put a link in the show notes so you can access that right now. I'm going to have a bit of a rant in a second, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Braley Roofing, Brian Bodie, Carabin, Chuck Hawkins, Commander Balok, Cy Nelson, David Gilton, David Matz, Dustin Cable, Evan Pro, Greg Feely, Hans Schultz, Hudson Ward, Jay Graves, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Smets, Michael Purcell, Modzo, Paul Roebuck, Ren Kaidu, Robeck, Sean Sargent, Stephen Fowler-Munley, Vlad Chiplin, and Wolfgang Klotz, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So I've been doing a bunch of banger interviews in the last couple of weeks, and I've been really proud of them. And yet there is this theme that I see in the comments, which has been, it's been getting under my skin a little bit. So we did a really cool interview about, maybe our technology has changed and it's possible to terraform Mars. And there was another interview about transpiration as a way to cool down spacecraft, as a way to help out heat shielding. And obviously, both of these ideas are complicated, terraforming Mars or using some kind of gas or liquid to be able to keep a spacecraft cool. And yet, there are really interesting technological advances that have happened. Jet engines use this transpirative cooling to keep the turbofans cool already. Like, this is established technology. So maybe there's a way to extend this to rockets. And there's like this theme in the comments, which is where people are saying, like, that's a dumb idea. It's never going to work. Why are you even doing this? Why are we spending money thinking about this when we could be saving planet Earth and so on, right? Why go to space when we don't know how to feed the poor is sort of like, you know, the catch-all argument for that. What I love, the thing that keeps me coming back to doing this work is I love when people are thinking through clever solutions to difficult problems. It's that process that I find so fascinating. And so I'm drawn like a moth to a flame when somebody has a clever idea to solve a long-standing problem in astronomy, or to people who are working on technology that will fix an issue with space exploration, with rockets, with exploration on the surface of planets. And so I can't get enough of that kind of stuff. And it's so weird to me that people will kind of poo-poo it and not want to talk about it, or like make a negative comment or whatever. Like, yes, we understand it is just an idea. Somebody looked at a problem and then thought, what would be a solution to that problem? And then wrote down the solution to the problem and then published it. That's as far as this has gone. That actual space exploration is a very conservative process. That hardware, rockets, needs to be tested in space before it can ever be relied upon. And we are so far away from being able to practically do this, but we have to start thinking about it at some point. And so I'm really glad that I get to be here and listen to the people who are thinking about this kind of stuff and ask them my questions and satisfy my curiosity. And I'm so grateful that I'm able to do this for a living. And I'm really glad that you get to come along for the ride and listen. So, you know, you can ignore the people who make those kinds of comments. It's not for them. It's for you. All right. We'll see you next week.